Hi friends, let's have a look at problem 2360, longest cycle in a graph. This is a daily challenge problem, and in this video we're going to explain a solution based on mimicking the find method in UnionFind abstract data type. First, let's look at the problem statement. This problem is marked hard by leetcode. So we are given a direct graph of n nodes numbered from 0 to n-1, where each node has at most one outgoing edge. So this is an important assumption. And secondly, the graph is represented with a given zero-indexed array called edges of size m, indicating that there is a direct edge from node I to node edges I. And if there is no outgoing edge from node I, then edges I is set to be -1. So we are required to return the length of the longest cycle in the graph. And if no cycle exists, we are going to return -1. So the last sentence or paragraph explains what a cycle is in a graph. So a cycle is a path that starts and ends at the same node. So here are two examples. In example 2, there is no cycle, so therefore the output is -1. And in example 1, so there is a length 3 cycle. Actually it contains 3 nodes also, so the output is 3. So the additional assumptions or constraints are the following. First, the length of the list edges is m, and n is bounded above in particular by 10 to the power 5, and the edges I is in between 0 and n. N is is exclusive, I would say, and the edges I can be -1, meaning that there's no outgoing edges. So edges I does not equal to I itself. It means that there's no self cycle. So with that said, we are ready to do the analysis. So actually this problem is a typical graph problem. So for detecting graph or find the length of the cycle in a graph is actually a routine task in graph theory. So here I'm going to explain or solve this problem using a method based on mimicking the find method in UnionFind or disjoint set abstract data type. So this is also a format of DFS, I would say, for the solution we are going to share. So here, first let me mention an observation. First, as each node has at most one outgoing edge, so each node belongs to at most one cycle. Therefore, we could mark visit node with edges node to be -1 in view of the assumption that edges I is set to be -1 if there is no outgoing edge from node I. So this way it can help accelerate the traversal if you would like to use the traversal language. So the idea actually is very straightforward. So we actually can consider node neighbor pairs. So actually can regard the neighbor as a parent also, if we like. Also we can think of this as node parents, as we mentioned in UnionFind. So how to find the root via find method for a node? For example, we have A has parents B, and B have parents C, and C has parents D, and D has parents itself, right? So the root of A or the ancestor of A is D. So this is in the setting of a find method in the disjoint set data structure. So in detecting cycles, the things are similar, right? If we have A connect to B, B connect to C, C connect to D, and D connect to A again, right? This means that we find a cycle. So if we compare the two scenarios, one is finding root in in disjoint set abstract data type, or we detect cycles in a graph. They are similar, right? So as for cycle length information, we can use incremental counting, or to make it simpler, so we can use index to do a recording, right? So with that said, I guess writing the code is actually rather straightforward. So you can actually make connections of this problem with other problems, like finding lowest common ancestor in a binary search tree, right? So it's actually good to practice. So with that said, we are ready to look at the code. So for the coding, first I'm going to initialize an answer variable. So the final state of this variable is what we want to return. And initially we set it to be -1. The reason is that if there's no cycle, we return -1. So once this done, so basically we want to do traversal. So here we are going to iterate, right, for ij in enumerate edges. So typically this means that there's an edge from I to G if G is not -1, right? So we can set previous and neighbor to be ig. So just for this set, I just want to make it aligned with the graph theory language, right? So that you can send them, you can digest or see the mainstream or in the larger scope. And then in order to detect cycles and record the length, I'm going to let's see, count, so to be 0. So this count is going to record the cycle length if there were a cycle. And then also we are going to have a path, right? So this is like the path in the find method in UniFind. Then what I'm going to do is to do a while loop. So while neighbor is not equal to -1, in other words, we can still retrieve up. And then what we are going to do, we are going to set path previous. So we're going to set to be count, right? So next time if we see another node in the path, then we're going to compute the count difference to get the cycle length. So that's one thing. And then we're going to do count incremented by 1. And then after we visit the current previous, then what we are going to do, we are going to set edges previous to be -1, which means that we have visited this node. We don't want to visit it again. And then what we are going to do, we are going to retrieve up in this path neighbor chain, right? So we are going to set previous. Let's see. We are going to set previous to be the neighbor, and neighbor to be the edges neighbor, right? So this way we move up to the chain, right? Then after this while loop, neighbor is going to be -1, and actually we find. So if there is a cycle, so basically we are going to compute the length, right? Let's do this check. If previous in path. So if this is the case, so we're going to set and choose the larger one, right? That is count minus path previous, right? So yeah, this is the way actually computes the path length, cycle length. So afterwards, so we can do the return, right? So this short a snippet of code forms a solution format to this problem. So before we make any comments, let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases fast. So I guess that's about it for this very routine problem. So here first I want to make several points. First is that each node has at most one outgoing edge. So this is one important assumption. Another one is that in the edges, if there's no outgoing edge, it's marked as -1. So we are also using this as a stop condition to avoid repetition. So another point we want to make is that this way of coding or solving this problem is in analogy with the two things. One is the find method in the unit find, or also known as disjoint set data structure. That's the one. Another one is that it's also similar to the typical task of finding lowest common ancestor in a binary tree. Right? You can find the two paths, and then you find the last common nodes. Right? So with that said, I guess that's about it for this video. You can actually explore more on how to code and in this problem, and explore different formats of solutions. That's about it for this video. Thank you.